can hear something that makes me mad.
Look good. Alright guys. Let me get one vertical here.
Alright.
Who's supposed to line?
Alright, ready? You guys enjoy the tour. What's going on, guys? Johnny with Blaze of Grass Lawn Care, and today I'm going to take you on a very special tour. Yup, guess where I'm at? I'm at the John Deere Manufacturing Company, and we're going to just walk around. I'm going to just kind of, show you around. So, some things we can't see, but that's okay. I'm going to show you as much as I can, and you guys are going to get the tour with me. So enjoy the tour. I think I'm your first stop on your tour of Turf Care. Well, I'm Connor, by the way. I'm one of the welding engineers. This is Travis. He's the weld tech that's running this robot. This is one of our Z9 frame robot. This frame we built here, North Carolina. Travis, you want to go ahead and load up some parts for us? So you'll see this big tool right here. Each part is loaded up into this weld tool so that we get consistent frames and good welds every time. As he's loading up this fixture, each piece is located and then clamped so that the piece stays locked in as it's being welded. As you guys know, you guys are probably familiar with welding, there's a lot of heat involved. Parts may shift, move around a little bit, and the tooling helps prevent any of that. The tooling also helps us see if we have a parts problem or not. So before I sweep this in, we'll talk about safety. These yellow boxes here, they're laser light curtains. So when the operator's working on the robot, he has to be outside of this line, and it's as it rotates. If any movement's done and he breaks this light curtain, then the robot will fault out. All the welding is done within the robot cell, which we'll see here in a minute. That way no one gets any arc flash, all the spark stays in. And if you look above us, we also capture and filter out all of our welding fume. So we'll go ahead and we'll get this robot started. The robot will index and it will sweep in. And then out comes a fresh baked Z9 frame. Right now we're inside the cell. The robot is actually moving around and it's touch sensing every piece to make sure that we've loaded the tooling and that we're not missing any components. Then it will start welding. Travis, do you want to go ahead and do your quality check? So because the robot's doing all of the welding aspect of this allows our technicians to go through and check quality. He'll go through, he'll clean his welds, he'll make sure that all the welds are in joint, he doesn't have any fit up issues. The holes that he just checked will bolt other components onto later on. So he made sure that all those are still in line after the welding process. The cycle for this frame is about 6 to 7 minutes. And we do all the frames and decks for Z9 get welded in robots as well. Once it's finished welded, right? Mm-hmm. How does he take it off?
So when it's done welding, you want to show him? So when it's done welding, the robot's controlled through this screen here. He'll hit this button that says unload. It will flatten out, and then his valves over there, he'll open them all up. You'll see the clamps open. The frame will pop out, and he'll move it over to a conveyor. That the conveyor runs behind these robots over to paint, which I think you guys will see later on.
All right, so this is the Z9 frame, which is our main frame that we run here. It takes about 68 minutes to run this machine. This machine is a very accurate machine running about 8 micron, which is about a tenth of a human hair. So it runs about 8 micron precision. It weighs just under 17,000 pounds. And a general rule of thumb that we have in metrology is that whatever you're measuring has a precision of 10 times more accurate than whatever the tolerance that you're measuring. So this machine is more than capable of everything that we have. And this room was built for this machine mainly. It stays 68 degrees all year round.
Measuring?
So it's measuring, we measure to the print that the design has. So it's measuring each feature, and it goes around and measures every feature that is on the print. With this one has about 200 features in it. So, and then it takes about, I want to say it's like 200 points per feature, and it scans. So it does a hard probe scan. So it goes around and scans every feature. And then not everything's perfect, so it has to do locates of every feature. So once it does its locate, it goes and measures everything that's in there.
Your automation and controls team at Turf Care, if you want to step around here a little bit further, what we're looking at on our assembly line, we use a lot of vision, and in those vision applications, we're limited to where we can mount the camera. So we mount the cameras above the catwalk, looking down at the machine. So we're looking at a static image of the machine while the operators are building it. What we did about 2 years ago is we graduated to an inline inspection audit. So what this is 2 cobots from Fanuc that are going through and they're inspecting the machine in places that we can't see with our normal vision systems. So again, with the vision systems that are mounted in the ceiling overhead, we're limited to what we can see top down, left to right of the machine. So as these robots are going through, we're inspecting parts of the machines that our assemblers are putting together to make sure we're putting out the best quality product that we possibly can. So this essentially is 100% audit of our A side on things that we can visually inspect. So things like torques, things like that are applied torques, we can't check those, but the vision system is going through. What you're looking at on the TV are the images that are going through the camera inspection. So we've got 2 Cognix inspection cameras. We use those throughout the facility, but these we attach to the end of the robot arm so that we could go through and inspect multiple things underneath the machine, inside of brackets, things that we can't see during the normal assembly process. So it's just one of the ways that we're trying to prevent mistakes from getting out to the field, getting out to the dealer, to the customer, so that we put out a better product at the end of the day.
So what just happened now?
So it passed. That's our pass. So we've got the visual cue with the green lights. We've also got the audible cue because the operators are back here working on their station. So while the robot is running in tandem with the operators assembling, they get that visual cue, that the visual and the audible cue to know that the robot is finished. The folks across the line can come pick it up. If they're done, they can load the next one in here. So we're going to load a new one in here. A lot of the things that we're looking for on these machines are the root clips, the clips that hold this entire deck linkage together. So those are things that we can't see during the assembly process because the frame is standing straight up. You may have noticed it coming down the conveyor earlier. So that's where the robot gives us the advantage. We can go back and look at our audit data from the audit findings from the week previous. If we miss something in our audit data, we can add it to the robot, add a new inspection to the robot, go through and inspect all those things on the fly. So this is a tool that we're using to increase our quality, to make sure we're putting out the best product that we possibly can. What you're seeing here, we're actually programming the display. So that's where the yellow cable comes down. That display is programmed, so we're writing our own software for those displays so that when the operator's in the field, they can look down and it's a little bit different display. You've got the fuel gauge on there. It shows you how much fuel is in there. So that's on the EFI machines that we have now. I appreciate you guys being here and thanks for what you're doing.
Hello guys, my name is Dr. Walker. I'm the C9 commercial department team lead.
And I'm Matt Gleason. I'm the manufacturing engineer, factory engineer for this line as well. We wanted to take y'all through some of our more robust mistake proofing that we use for this line. Oscar, if you want to go ahead and assemble some of these. So this is the blade to the spindle. So the actual blade under the mowing deck here. You know, and of course we want to use some of our more robust mistake proofing when it comes to something as critical as blades, right? So he's going to get his sleeves on here because he's working near these blades.
And what we look for here, you know, all over this line, we're counting torques. I mean, it's something we do everywhere, right? But in this case, we want to do a little bit more than that. So we count the torques. We actually record the torque values to our database and save those values to the serial number of the machine. And you can see here he's weighing the blades to make sure he's got the right ones. And then we also want to make sure we have 3 unique good torques for this, which is a little unusual for this line. So we've got a separate system here called a POSIX. And what that does is it reads a good positive torque from our Stanley tool here, and then it allows it to move to the next one. So if we ever end up in a situation where maybe some hardware is bad, maybe there's a burr on the threads, something keeps us from achieving a good torque there, it won't let him move on until that one's been addressed. So instead of him making 3 torques and now we've got 2 good torques counted and he doesn't know which one, he can't move on until that's been addressed. You can also see he's using this curved washer here. This tool's also set up to identify whether that curved washer's been put on upside down or not. So if you want to go ahead and do the first torque, Oscar, you can see the tool runs just fine in its first position. And then once it achieves a good torque, you see it turns green, you move on to the next one. Try to do that third one, Oscar. So the tool won't run in the wrong position. If you put it in the right position, you move it to the right position and it should run down just fine. And that will allow it to move to the third, and then it'll move back to the first once it's done here. So she's going to grab some spindles for us. So we do this, we torque the spindles to the deck and then our spindle sheaves to the spindles in the same way with these multi-spindle tools. So this one's a 6, this one's a 4. They work the same way. What they do is they all run down to a specified snug torque, and then we bring them all to final torque together. That keeps us from having to torque in a star pattern or anything. We don't have to ensure that the operator's done that right. It does them all simultaneously. We also count these torques and record them in the same way as that other tool. Not realistic that he would do that. So we're going to bring them all down to the exact same point and then make that final torque together. Go for it. Process complete.
My name's Kent Holmes. I'm the supervisor for technical quality here at Turf Care. Just want to talk to you a little bit about what we do from the quality standpoint for these products. So what you're looking at here, we do a combination of a static audit, which means a machine like you see here sitting on the cart. We're checking about 135 different items on them, and that varies throughout the year depending on the feedback and stuff we get. And we also have a bunch of different models, so it may be more things on other machines as well. But we're checking everything from visual indicators, functionality, stuff like that. And during the static audit, we do about 20 a day, right? Currently over here. And if there is anything we find, we always flex up and back to make sure if there's any issue, a reoccurring issue there. And then also a couple times a week, they do a performance audit as well. So performance audit, they outfit it with seat, and they drive it outside. They're checking the blades and stuff like that too. So in conjunction with everything they've done so far on the assembly line that you've seen with the robot checks and the run-in and stuff like that, we're also checking them periodically here down at the end. All right, that was a review of what we do down here for static and performance audit. Any questions for me?
How often do you find a mistake?
Okay, so the question is, how often do you find a mistake? It can vary a little bit. Sometimes anything from like a little bubble in the decal, crooked decal, stuff like that. We're building quite a bit. This is our busy season, so we do find a little bit more than often. But they do a very good job of tracing it back just to make sure it's not a reoccurring problem as well. All right. Thank you, guys.
Good morning, everyone. Welcome to Turf Care Paint Shop Department. My name is CJ. I'm a waste treatment, pre-treatment technician, and I'm going to walk you through our facility treatment plan So please follow me. As you guys can see right here in this table in front of me, these are some of the parts that we process here. Just be mindful, we're going to work under the conveyor. Just make sure we stay between the yellow lines, start away from the blacks here. As you can see here to my left, this is one of our cleaning stations, stage 1. That's the alkaline, which will remove all the particles and everything from the part. The tanks are about 1,000 gallons water, and we'll dump them every so often. Then the parts will travel to a rinse tanks, which is the city water. We don't use any chemicals or anything on that one. Once it goes through stage 2, we'll go to a stage 3, which is a phosphate. Then we'll apply it. We'll go to another rinse tank, which is a stage 4. Again, that's another 1,000 gallon tank. Stage 5, that's our non-chrome seal. This is what kind of the final for the pre-treatment process. Then stage 6, this is another rinse tank that it'll take the parts right into the eco tank. As the parts travel, eco tank is right here on my left hand side. The parts will deep in there and they're submerged for a good 5 minutes or so. Once the parts come out, then we have 2 post rinses to remove any excess of eco on the parts. Once the parts are all the way through a pre-treatment eco system, they'll go through this oven right here. This is 455 degrees. This is how parts comes out right after pre-treatment and eco treatment. And now it's ready to be powder coated. So right here, right in front of me, this is how we apply the powder coating on the parts. We have 16 automatic guns and 2 manual guns. With 2 operators, we touch up most of the parts that comes to our process, and this is how we apply our green powder. Once the oven temperature start hitting, the powder start melting into the parts, and then we'll show you the process, how the parts come out on this side of the oven. So this is our final process here, right before parts go back to assembly, so they can start assembling.
We have a name for the green. This green paint actually have a name, or is it just John Deere green?
John Deere green.
John Deere green.
John Deere green.